Yeah, my name is Yuhao and I'm from Intel Big Data Technology Department. Actually, now I'm a developer in the BigDL team, and before that, I was actually focused on contributing to Apache Spark, and I contributed like linear SVC and RDA, and I figured out several algorithms in Spark. So now we are focusing on BigDL, which is a deep learning library on Spark. Okay, so what is BigDL? So basically, BigDL is a deep learning. It's actually a native deep learning library on Spark. We built the library entirely on Scala, and we provide Python interface. So that's where BigDL would locate in the software stack. We are basically in parallel with Spark ML Lab, and we have provided the interface for Spark ML pipeline, so you can integrate it with BigDL functions and CQ and streaming and ML Lab. So about the basic components. So for building a deep learning library on Spark, we have to provide a few elementary elements for any deep learning applications. So start we got tensor, which is basically a multi-dimension matrix array structure, kind of like the ND array in Python. And it's a generic data type. Currently we support float and double. So the key point about the tensor is that all the BLAS operation behind it are backed by the Intel MKL library. MKL stands for Mass Kernel Library, and with the help of MKL, we can have comparable performance with GPU on actually many deep learning applications. And actually, if you have built any deep learning applications, you will know no matter it's fully connection or convolution or RNN, at the core part of all the deep learning networks, the core operation is called GEMM, which means multiplying to matrix. And by leveraging MKL, the multiplying of matrix can be accelerated by orders of magnitudes. So after that, we provide layers. Here in BigDL, currently we provide over 200 different layers, including the common convolution, RNN, and fully connection, and all kinds of criterion. So for the criterion, basically, it's for different types of deep learning tasks for regression or classification. And for optimization, we provide SGD, LBFDS, ADAM, AdaBoost, and basically everything popular. In the model zoo, we have built, well, here's a list of the models that we have implemented on BigDL. So AlexNet Inception, ResNet VGG, and MobileNet for image classification, SSD, faster RCN for object detection, and wide-band deep learning, neural recommender DeepFM is for recommendation. And we have provided some industry applications also in the model zoo. I will give more details later. Okay, so what's in BigDL? To summary up, we have Scala and Python interface, and we have built a lot of applications which can integrate BigDL and Spark ML and Spark streaming. And the interface, the programming interface is actually quite similar to Spark. So any Spark developer should find the API pretty intuitive. And we also provide support for Jupyter Notebook and visualization through TensorBoard. Users can also load Caffe, Torch, or TensorFlow models into BigDL and do fine-tuning after that. And another great thing about BigDL is that I talked earlier about MKL, and it's actually a library written in C. So we have wrapped the C files and make it an independent jar file. So when deploying BigDL, you just need to copy the jar file of BigDL along with your application code to the cluster. So there's no operation, actually, there's no any operation required for deploying BigDL applications. just like submitting a normal Spark job. Okay, so we have get the support from all the primary cloud providers, including Azure, AWS, and Ali, and Cloudera Databricks. So they have all published blogs about how to use BigDL on their platform. And BigDL was open sourced on December last year. So currently it's collecting over 2,100 stars, and we got a lot of contribution from the community. Right now, Intel has a developer team of about 30 developers focusing on the BigDL development. So we are pretty committed to making this project successful. So who is using BigDL? And we are actually cooperating with a lot of our partners in different areas. For consumer side, we got Gigaspace and MLS listing. And they are basically, well, I will talk about that two use cases later. Actually, Gigaspace is using BigDL for speech recognition. MLS listing is using it for finding similar homes for the users. And UCSF is using it to process its 3D images from MSR. And from finance, we deployed BigDL in UnionPay for its fraud detection system. And for China Life and MasterCard, we built a recommendation system for it. And JD.com is a heavy user of BigDL. Actually, they got a Spark cluster of thousands of nodes. And they found they replaced their deep learning, they replaced their GPU-based deep learning cluster with BigDL on CPU because they found, well, it's just more naturally to develop deep learning applications on the data that's already in the big data on their Hadoop clusters. So using BigDL has several advantages. First, you get most of your big data software engineers are pretty familiar with Hadoop and Spark and all its APIs. So you don't need to get your developers to learn anything new for running deep learning applications. The second thing is most times your data is already in your cluster like Hadoop or HDFS or HBase or Cassandra. So by using Spark and BigDL, you can just access your data natively. And the third is actually for BigDL, it's much faster compared with other deep learning library because we have the MKL acceleration. And actually, the target of BigDL is to get comparable performance with GPU cluster. Okay, so next is Bob Steele, and he's from steel manufacturing, and he's using BigDL to detect the product defects. And Cray is another platform provider for science computing. Okay, so next I will go into more details for each of the industry application as an example, and I will try to tell more details about each of the application, which kind of algorithms we use there, and what kind of result we get. So first is from JD.com. The user scenario is pretty straightforward. It's just to find similar products based on images. So to do that, the first step is to detect the object from an image. Like initially, we need to pre-process all the images, and then we need to send it through the SSD model so we can detect certain object from an image, so we can filter out all the background noise. And after we get that part, actually it's a crop from the image, we can use that to get it through the deep bit model, which will calculate a binary representation for the image. The binary representation can be used for image similarity search or just the image query. And the result is cached in HDFS system. The next case is about the pre-processing part. Actually, BigDL focuses on providing end-to-end solution for the users. So we have provided all the necessary steps for the image argumentation. And the steps defining here, like the image transformer is actually extends from Spark transformer, so you can natively fit it into any Spark ML pipeline you already have. And we provide all the steps where you can just define the parameters. So for next example is from real estate. Basically, if you have searched the house in the Bay Area, the agents will upload all the metadata of a house, like the attributes like size, the price range, and how many bedrooms, and other attributes. And they will also upload a bunch of images, including the interior and the exterior of the houses. And usually it's not until you see the image of a house you can decide whether you like the house or not. So MLS listing actually is developing an application to find similar houses based on images with BigDL. For this project, it's actually a kind of hybrid system where we build 3 image classification tasks. First, we try to classify each of the image to add tags to each of the house, like whether it's a ranch style house and or it's a contemporary or it's a traditional style house. So there's a style tag. Another tag we add is the story tag. How many stories are there for a house? Is it a single story, 2-story, or 3 and plus? And with those tags, so we can get a basic classification for the house images. And for the similarity part, we actually use image embedding from the VGG network. We use the VGG 16 here, and we use the first linear layer that's immediately after pulling 5 layers of the VGG network. It's about 25,000 of flows. It will generate about 25,000 of flows for each of the image, and we use that as the embedding for each of the image, and compute cosine similarity to calculate the similarity of each of the image. So that's the final result. So in the final result, we combine the tags and the similarity image embedding to calculate the final similarity. Okay, next example is from GigaSpace. Well, the example is basically just it's for customer service support. And basically when a customer calls through the phone, he can tell you, briefly describe the problem he has. And then we will use speech recognition to convert those speech into a text. And we will use text classification to classify it, to actually route it to a special, here we call it, a specialist in a specific area. Like a user, if he has some problems with his mic, then we'll just transfer it to an Apple specialist. So that's the basic idea. In this application, we used both speech recognition and text classification. And the link below is a GigaSpace blog about how to build it with BigDL. So about the fraud detection use case in UnionPay. This was a long project, and it was actually developed over 3 months. And the first steps are, collecting data and do some initial analytics. So we can generate some extra features like how much money has a user spent in the last 3 months, and what's the last location of his transaction. And after that, we feed all the data into a feature engineering pipeline, where we do some resampling and imputation and indexing. The resampling is especially important for the fraud detection use cases, because in any fraud detection use cases, the training data will be highly imbalanced. Usually there's only 2 fraud transactions in every 10,000 normal transactions. So you have to, here we use resampling to resolve the, data imbalance. And for the model part, we actually used ensampling of neural networks. Earlier, we tried with tree-based models like random forest or GBDT, but turns out, ensampling of neural networks get a better accuracy for this one. And for each of the model, the small neural network in the ensampling, we actually resampled the data from the original data, resampled a part of the data from the original data. So actually each model will be feeding different training data. And for the prediction, all the neural networks will come together and vote and to see if a transaction is fraud or not. And here's, you can try with different voting strategy to see which gives the best result. We use the grid search, actually improved grid search from Spark ML Lab to do the parameter tuning. Okay, so next, and is for China Life Insurance. It's a neural recommender example. Well, the network is pretty straightforward, actually, for each of the user and item pair in the, training data. We will try to extract the embedding for each user and each item. So quite similar to other, deep learning-based recommendation engine. And with the lookup table, you can efficiently get the embedding for all the users, and it can be used in multiple scenarios. Besides, recommendation, you can find the similar products or find similar users. And the model part is quite straightforward. Yeah, we got deep learning and deep part and GF part. Also, I didn't include it in the slides, but we also support wide and deep model in BigDL, and if you check it, you can check it in the analytics tool of BigDL. Okay, so here you are welcome to partner with us. Actually, right now we are still promoting BigDL to the industry, so we can provide. Actually, Intel does not provide commercial solution like Cloudera, but we can provide support if you want to use BigDL in your applications, or we can help you develop it and provide some consultation. So welcome to partner with us. And the following links are, the links at the bottom are the GitHub repository for BigDL and some use cases from Intel side. So thank you, everyone. That's all.
We've got some time for questions.
So mandatory question, how do you compare to TensorFlow?
Okay, in terms of function parity, we pretty much reached the same level. Basically, every model that TensorFlow can support, we want to support it in BigDL. And we are also, actually, BigDL just released its 0.3 version, and in it you can just load all the TensorFlow model you want. Not only the trained model, you can actually load the model definition file from TensorFlow and load it into BigDL to continue training. So we try our best to support all the TensorFlow users. And we actually want to help you to migrate to BigDL on your Spark cluster. Okay. And in terms of performance, actually we tried several kinds of deep learning applications. And the target here is really to compare BigDL on CPU cluster with TensorFlow on GPU clusters. So we can really be compatible in the market. And from my personal experience, most times we can get comparable performance. Sometimes we can get like 80% of TensorFlow on GPU cluster. Sometimes we get a little better than them. Actually, JD.com tried it, and it found that BigDL actually runs 3 times faster than TensorFlow on their GPU cluster. So they switched to BigDL.
Given that you have both Scala and Python bindings for BigDL, do you see use cases where, say, feature engineering is done with Scala and then data science engineers may use Python for model training? And if so, how do they interact or interop between those two languages?
Okay. For most of the production development, I see a lot of usage for Scala interface. Well, most times because well, Scala is more type safe and easy to test, and for their production environment, usually they do not allow any change to their cluster environment. So they would just deploy the Scala-based BigDL applications because it's just as deploying any standard Spark program. It's just a jar file, and you don't need to change anything on your cluster. However, to run Python on your cluster, sometimes you need to install Python on each of the work nodes. Sometimes that can be a blocking issue, and but for prototype development and data scientists, we do see a lot of people using Jupyter Notebook, so we are supporting that.
Okay, and that runs us out of time. If we could thank Yuhao one more time.
Okay, thank you.